Good day, colleagues. Now I'd like to propose to your attention our work on the input material flow model of the transport conveyor. Belt conveyors are one of the main types of permanent transport in mining industry. The total length of the modern conveyor type transport system exceeds 100 kilometers and the length of separate sections is up to 20 kilometers. Despite its apparent simplicity, a transport conveyor is the complex dynamic distributed system which implies a transport delay. The main characteristics of long conveyor transport system is presented on this slide. The cost of energy for transportation is a significant part of the cost of the transported material and of the mining cost as a whole. Synthesis of algorithms for optimal control of the flow parameters of a conveyor-type transport system is a way to reduce the specific energy consumption for material transportation. With a material load factor of 70%, the transport cost is, in general case, at 20% of material cost. To increase the material load factor, the transport system is divided into sections. When designing a control system of the conveyor-type transport system, the analytical model was proposed as a model of a conveyor section. Two main types of these models are usually used. The first type is distributed numerical models. And the second type is aggregated models. In previous papers, it was shown that the analytical PIKH model is the most effective tool for describing the transport conveyor. However, the efficiency of this model decreases with an increase in the number of sections in the transport system. At the same time, the tendency to increase the extraction of material in the mining industry requires a significant increase in the number of sections in the transport system. In this regard, the problem of building models of the transport system containing a large number of sections becomes an urgent problem. This circumstance explains the recent appearance of a sufficient number of works devoted to use of a neural network for modeling a transport pipeline. The main problem that hinders the widespread of use of neural networks for building these models is the lack of appropriate data sets for training a neural network. Why is that? In many cases, collecting data for training is not possible. This is because in order to collect the data, it is necessary to operate the transport system in economically unfavorable conditions that require significant expenditures of material resources or in conditions that can lead to destruction of transport equipment and system as a whole. One of the ways to solve this problem is to build input flow generators, provided that the model of which is based on production data. In this paper, a method for generating those data sets for training a neural network was considered. The main goal was to form a countable number of data sets, which characterized by a certain correlation function and a distribution law, that can be used to train a neural network. For that, there was necessary to support or decline some assumptions made in publication, in particular assumptions about correlation function and the distribution law of the input material flow of transport conveyor. We assume that theoretical assumptions must be substantiated by experimental results. Our analysis was made based on the assessment of functioning system experimental data. The statistical data of input material flow was taken for the bucket wheel excavator SR2000. As a result, it was demonstrated that hypotheses put forward about the normal law of distribution of material input flow value doesn't correspond to the experimental data. On the other hand, the existing recommendations that the correlation functions can be approximately represented in exponential form are confirmed. This is an important result of the present study. Although the additional studies of works that present experimental data of the magnitude of the input material flow for modern transport conveyors are required. The analysis and generalizations of the obtained results will make it possible to form a countable number of data sets characterized by a certain correlation function and distribution law of a random variable that can be used to train a neural network. A transport system model based on such neural network can be used in the synthesis of algorithms for optimal control of a conveyor section flow parameters in order to reduce the specific energy consumptions for material transportation. Thank you for your attention.